The cometary Oort cloud. The Oort cloud is an object that first thought by Ernst Öpik, an Estonian astronomer. He tried to find out where the comets come from, so he proposed that there is a region in the solar system that can produce these comets. After that, Jan Oort, a Dutch astronomer, picked up on the idea and worked on it. He proposed that the comets must not have formed while it is in the current orbit, which is an orbit close to the Sun. The comets must have formed somewhere far away due to the perturbation of gravity from the nearby star. The comets then got shot toward the Sun. So now we call those region or Oort cloud in honor of the astronomer. We cannot directly observe the cloud because if it is there, it's really far away, too far for our current technology to fly to. Also, we cannot observe from the telescope because this region would be so cold that it doesn't emit enough light to be detected on Earth. There is only one way for us to determine its shape and size, that is to create a model of region of the Oort cloud. The first one is the inner Oort cloud, which is about 2000 AU to 20,000 AU, and the other one is about 20,000 to 50,000 AU. The first region, the inner part, was proposed by Jack Hill, which he says that it is in the shape of a torus, similar to the donut. As for the outermost region, it is said to be a spherical symmetric shape. Between these two regions, the model also predicts that the comet-rich region is the inner part. This model needs to be supported by the comets that Scott observed. From the observation of the comets like Halley or Hale-Bopp, we are able to determine the mass and size of roughly of the Oort cloud. However, since the only observation we have related to the Oort cloud are the comets, we cannot really determine what shape really is. Even though we want to firmly say whether the Oort cloud is sphere or torus, we cannot. But according to the model, we can say that the comet's region is in the inner Oort cloud. So if we want to represent the Oort cloud, we might be able to say that it is the inner region. Therefore, it should be shaped like torus, rather than a spherical symmetric shape. The planet and asteroids all lie close to the ecliptic plane. This statement is partially correct. Most planets and asteroids lie in approximately close to the ecliptic plane, with some small degree of inclination. From the table in the first column, we can see that all planets are close to the ecliptic plane with some inclination. However, it's not more than 10 degrees. The problem lies in the asteroids. If you look at the next diagram, which shows the distribution of the asteroids in the solar system, especially in the asteroid belt. The asteroids are represented by the scatter plot of blue and yellow. The yellow dots are asteroids in the core region of an asteroid belt. The blue dots are asteroids not in the core region of an asteroid belt. From this diagram, you can see that not all asteroids lie close to the plane. There are asteroids in the core region that incline from the plane, and also there are asteroids not in the core region that incline from the plane. What could be the reason? For anything to incline at all in the orbital plane, is related to angular momentum conservation of the solar system. If we go back to the formation of the solar system, the collapsing cloud in fall to the center of the region and form a star. The remaining material will accrete around the protostar. This accretion later becomes planets, asteroids, dwarf planets, and the other objects. These objects exert gravitational pull to each other, perturbing each other orbit. This perturbation makes the orbits become elongate. But what about the inclination? Because the force is exerted, the orbits become perturbed. There are another way for the system to conserve their angular momentum, that is to change the position of the orbital object from the normal plane of orbit. That's why planets and asteroids are inclined from the original plane. The outer planets are all gaseous. What is gas? When we talk about gas, we originally think about something that is combustible, flammable, or breathable, like hydrogen, oxygen, ethanol, methane. On an occasion like in the classroom or in the lab, that we will use the physical meaning of the gas, which is a state of matter. To say that the outer planet is made of gas, it mostly represents the composition of the planet, because the outer planets are composed of something like hydrogen, helium, methane. In this sense, it is correct that the outer planets are made of gas. However, if we want to use the physical concept of the gas, then the outer planets are not really a gas planet. It is more appropriate to say that the outer planets made of hydrogen, helium, methane, and other kinds of composition. The reason being that matters can change state. That means it can change from solid to liquid, or from liquid to gas, or from gas to plasma, depending on temperature and pressure. Look at this diagram, for example. This is a phase diagram of the hydrogen. At low temperature, hydrogen can become liquid, or at the extremely high pressure, hydrogen can also become liquid. This extreme condition didn't really appear on Earth naturally, but on a planet like a Jupiter, which has strong gravity, it can change the hydrogen to become liquid. Look at this diagram, we can see that Jupiter divided into layers. The outermost is the gaseous hydrogen. When we dive down further into the atmosphere, we can see that the pressure becomes higher, thus compress the hydrogen to become liquid. And then if we go to the deeper part of the atmosphere, we can see that it's compressed even higher and become metallic hydrogen, which is also liquid. With this diagram, we can also see other planets inhibit the same properties as Jupiter. Therefore, we can't really say that they are made of gas because they compose of both gas and liquid. It depends on what definition of gas that you want to use. If we use the word gas in general sense, then these planets are gas planets. But if we want to use the gas in physical sense, then these planets are not gas planets. It is better to be more specific about its composition, like Jupiter and Saturn are mainly made out of hydrogen.